Welcome to Echoes of Singularity. In this video, I'll be talking about the different components of intelligence in AI. We often hear about AI being intelligent, but what does intelligence actually mean for AI? In this presentation, we'll explore the different ways AI learns and processes information to perform tasks efficiently. Intelligence in AI isn't a single concept. Rather, it consists of multiple components, just like in humans. AI systems try to replicate these aspects of intelligence to solve problems, make predictions, and even interact with us in meaningful ways. Our focus today will be on the learning aspect of AI, which is one of the most crucial elements in its intelligence. At its core, learning is the ability to gain knowledge and improve over time. Just like humans learn from experiences, AI learns from data. The more data it processes, the better it performs. For example, YouTube recommends videos based on what you've watched before, and email spam filters detect unwanted messages by analyzing past spam emails. But how exactly does AI learn? Let's dive into the different types of learning methods used in AI. AI primarily learns through three different methods. First, we have supervised learning, where AI is trained on labeled data. Imagine showing an AI thousands of images of cats and dogs, it learns to distinguish them. Second, we have unsupervised learning, where AI finds hidden patterns in data without labels. This is used in customer segmentation, like grouping similar users for targeted marketing. Finally, reinforcement learning is when AI learns through rewards and penalties, just like how a child learns to play a game by understanding what leads to winning or losing. The first and simplest form of learning is rote learning, where AI memorizes facts without understanding them. It's just storing and recalling information. Humans do this too. Think about memorizing multiplication tables without knowing why they work. In AI, a chatbot can store predefined responses and answer basic queries, or a spelling checker can compare words to a stored dictionary. However, this type of learning has a major limitation. AI doesn't recognize patterns or learn from mistakes, it just retrieves stored information. Next, we have learning by instructions. Here, AI follows explicitly programmed rules to perform tasks. It doesn't learn by itself but follows a fixed set of rules given by programmers. For example, in real life, if you're following a step-by-step tutorial to solve a math problem, that's learning by instructions. In AI, a GPS system calculates the shortest route based on predefined rules, or a chatbot gives fixed responses based on programmed instructions. The drawback: AI can't improve beyond the given rules, it's limited to what it has been programmed to do. Now we come to a more advanced form of learning, learning by analogy. This is when AI compares a new situation with a past one and applies the same logic. For example, a doctor diagnoses a new patient by comparing their symptoms to previous cases. AI does this in recommendation systems. Netflix suggests movies based on your past behavior and the preferences of similar users. Similarly, fraud detection AI compares current transactions with past fraudulent ones to detect suspicious activity. The advantage of this method is that AI can apply past knowledge to new, similar situations, making it more adaptable. Now, let's move on to learning by induction, which is all about pattern recognition. AI looks at multiple examples and generalizes a rule from them. Think of a child who sees many different dogs and eventually understands what makes a dog a dog. In AI, this is how spam filters work. They analyze thousands of spam emails, identify common patterns, and use these patterns to detect new spam. Similarly, image recognition models learn from multiple images and recognize objects in new images. The advantage of this approach is that AI can make predictions even on new, unseen data. Finally, we have learning by deduction, which is the opposite of induction. Instead of learning from examples, AI starts with general rules and applies them to specific cases. Humans do this all the time. For example, if you learn that all metals expand when heated, you can predict that a new metal you encounter will also expand. AI applies the same logic in areas like medical diagnosis. If it knows that fever plus sore throat equals likely flu, it can diagnose new patients. Similarly, in legal AI, general legal rules are applied to specific cases. The advantage here is that AI can make logical decisions based on established knowledge. Let's take a step back and compare all these learning types. Rote learning is simple memorization, like a chatbot storing responses. Learning by instructions involves following predefined rules, like a GPS system. Learning by analogy helps AI make decisions based on past experiences, like fraud detection systems. Learning by induction allows AI to recognize patterns and generalize, as seen in spam filters. Finally, learning by deduction helps AI apply general rules to specific cases, like in medical or legal AI. Each learning type has its own strengths and limitations, and AI often uses a combination of these methods to function effectively. Wrap up, AI intelligence is built on different learning methods. Each type of learning has its own strengths. Some are good for memorization, some for pattern recognition, and some for applying rules logically. Understanding these components helps us appreciate how AI functions and where its limitations lie. With advancements in AI, we continue to improve these learning models, making AI systems smarter and more adaptable. That brings us to the end of this video on the components of intelligence in AI. I hope this helped you understand how AI processes information. If you found this useful, don't forget to like, subscribe, and share your thoughts in the comment. Up next, I'll be exploring the different approaches to AI, so stay tuned for that.